Hello guys, welcome to my channel, and I'm gonna solve the bitwise end of numbers range, which is number 201 in Leetcode. So we're given a range from m to n, where m and n is bigger than 0 and smaller than the maximum value of integer. So we have to return the bitwise end of all numbers in this range, inclusive. So let's see an example. We have two numbers which is expressed as binary number. So end operation is compare two number which is 0 and 1. If the 1 and 1 becomes 1, and 0, 1 becomes 0, and 1 and 0 becomes 0, and 0 and 0 becomes 0. So if I use end operation for those two numbers, it becomes 0, 0, 0, 0 in this case. Okay, so then let's see another case. We have 1, 0, 0, 1, and 0, 0, 0, 0, which is 0 as an integer number. If I use AND operation for those two numbers, I can get the 0, because whatever the number of comparing is, if that number meets 0, it becomes always 0. So we can get the first rule from this case. So any number and 0 becomes always 0. Right. I just enumerate all numbers from 1 to 15. So that corresponding the binary number to each integer number. Then I'm gonna find the simple rule with two numbers. Okay, so if you see 1 and 2, I'll show you more examples, then you can find the rule between two numbers. Why I just used red rectangles between those two numbers. Okay, so 1 and 2, 3 and 4, 7 and 8, and 15 and 16. Do you get why I used why I highlighted those two numbers? Let's see from the first. 1 and 2. So 1 has just 1 as a significant digit, but 2 has 2 digits as a significant digits, right? And let's see 3 and 4. 3 has 2, and 4 has 3. And 7 has 3, but 8 has 4. And 15 has 4, and 16 has 5. What does it mean is that if you use AND operation between those two numbers, you can get always 0, because the digit is not the same. So the border of those range becomes always 0. So 1 and 1 0 becomes 0, and 1 1 and 1 0 0 becomes 0, because if you see the 3, it is smaller than 4, which is the three digits smallest 3 digits number, but it is smaller than 4. It's -4 -1. So it must be the biggest number which has two significant digits. And 7 is also the biggest number in in which has 3 significant digits. But if you meet 8, those 3 digits becomes all 0, and it increases the 1 digit, and the first digit becomes 1. So anytime you when use AND operation between two numbers, you can get always 0. So it means that number of significant digits in start is not equal to number of significant digit in end. The result becomes 0. So if you see the 7 and 8, the number of significant digit in 7 is 3 and 8 is 4. So it is not same. So if the range include those borderline, the result would be always 0, because any number with end 0 becomes 0. So if you include at least 1 0, the result will be always 0. Okay, so then now we can get is that how about we don't include the range of the border, like this example. So from 8 to 15, those range does not include the borderline. So let's say the start number is 9 and end numbers is 14. If you see those numbers, all we can get is, if I use AND operation among those two numbers, what I can get is the first digits are all 1, so I can get at least 1, at least 8, because the first digit in the 1 in 4 numbers, it becomes 8, right? So now you can compare the rest of digits in those numbers. As you can see, those three digits, you can see another pattern as you saw before. So if you see the first line, and you can find the borderline of those two numbers, 11 and 12. If you see the second digit of those numbers, you can see the first digit is 0, and second digit the 11 of first digit is 0, and 12's first digit becomes 1. So what I can get is those number becomes 0, right? As this way, you can calculate the all rest of digit if this number does not include the borderline. Alright, then let's dive into the code right now. I'm gonna use the Bitwise AND function, which is getting parameter m and AND. So first I'm gonna compare those two numbers, because if the two numbers are same, I'm gonna return this number itself, because if the number 5 and 5 same number, it becomes 5, because the 1 and 0 consist of those numbers are same, the order are the same, and all number of ones and all number of 0 are the same, so it's gonna return the number itself, m or n. So I'm gonna just use m for this case, and I need variables, which is start, which is m, and end range, which is n for this case. And what I'm gonna do is I need count variable, count 1, which is 0, and count 2, which is 0 also. And what I'm gonna do is I'm gonna divide those numbers by 2, and I'm gonna find what those numbers are in which scope. So if the number is in this line or that line, I have to find if the significant digits of starting number and end number, and I have to compare them, and if it is not same, it's gonna be always 0 for the result. So I have to find what the number is in which scope. So until m is smaller than 0, and I'm gonna, oh no, sorry, it's not m, it's I'm gonna divide by 2, and I'm gonna count it, and also until it's 0, I'm gonna divide by 2 and count those numbers. So I can compare those two numbers, count and 1 and count and 2. If it is not the same, it means that the range is including the borderline. So what did I say? If the range includes borderline, it is gonna be always 0 in that case. And if it is not, I have to get the first digits of those two numbers, because if the scope is same, the first digit would be always 1. So I can get those 1 from that numbers. So that numbers would be the leftmost number. It becomes the power of 2 and count minus 1. This number is our important number. We can add those number into our array. So, and I'm gonna return it with ln plus and bitwise and m and n again, n minus lm and n minus lm, because I have to subtract the lm from the start range and the end range. So through this way, I'm gonna calculate the significant digits recursively. So if I use this algorithm, I can get the result of all numbers in the range. So I have to return bitwise int and then passing the parameters m and n. Alright, so let's submit this algorithm. Oh, what is this problem? Declare CNT is not. Oh, I'm sorry. So because CNT1 and CNT2 are same, whatever you use, I'm gonna use CNT1. So sorry for the mistake. Yeah, it worked perfectly. Okay, so thank you for watching this video, and see you next time. Bye.